Our friend Tom, he wants to conduct one experiment, and this experiment requires a big size bowl of fish that is more than 750 gram, big size. Is it easy to catch this bowl of fish? If later on we calculate and find the priority number is very big, then yes, it's easy to catch. We have another friend, his name is Jerry. He also want to conduct one experiment, this time special a little bit because as long as 4 fishes that he catch is average 775 grams, more than, then it's fine. So his case is special. We also want to find what would be the probability that he can manage to catch average 4 fish is more than 750 grams. If the number is big, then we can say that it's easy to catch. So 3 of us go to a lake, and then we met up with the lake owner here. And the lake owner says that, oh, my lake got a lot of bawa fish here. If you want to catch a 600 gram bawa fish, there's a lot, many, the most. If you want to catch 200 gram, yeah, got some. 800 gram, okay, got some. If you want to catch the 1000 gram, the tiny, miny one, just a little bit. The very huge one, just a little bit. We see that the bawa fish weight, when we plot against the numbers of it can form one beautiful bell shape. So we can know that this is a normal distribution bawa fish lake. The lake owner gave us another information. He says that the population mean is 600 gram, average is 600 gram here, and then the population standard deviation is 90 gram. So now we want to help Tom to find what is the probability number. We're going to use these 4 big steps to help us. Step number 1, what do me and Tom want? We want to catch one big bawa fish for our experiment. We hope that the probability to catch this one big bawa fish is big, because when the number probability is big, then it's easy. Step 2, what do we have? Based on the information given by the lake owner, we know that the population mean of the bawa fish weight is 600 gram, and then the population standard deviation is 90 gram. We also know that this problem can be solved under the normal distribution model because we have a bell shape plus our weight is continuous data. How to solve the problem? There'll be 3 steps how to solve it. The first step is we want to mention our variable, the bawa weight, do follows the normal distribution model. The second step is we want to convert the weight of what we want, that is 750 gram, to a z-score, the z number. How can we do the conversion? We can use the z-score formula to help us. Step 3, we want to convert the z-score number just now into the probability number. How to convert? We're going to use the z table. Okay, step 1 inside the step 3 here. Step 1, mention the variable. So we're going to mention that our fish variable weight bawa follows the normal distribution model. The population mean is 600 gram, and then our variant, that would be the standard deviation square, is 90 gram squared. Second, convert the weight to the z-score. So what we want is more than 750 gram. We have the weight. Now we want to convert the weight becoming the z. So we will write the weight becoming the z and use this formula, the z-score formula. So x is what we want, 750 gram, and then mu is the population mean, and then sigma is the standard deviation. So later on we have our z is more than 1.67. So go to the step 3 here. We want to convert the Z score 1.67 becoming a priority number. We're going to use the Z table to help us. One of the resources to get Z table is z-table.com. So the Z table will be like this. Now we want to identify where is Z 1.67. Z is 1.67 here. So we have the number showing the probability is 0.9525. Because we want the area from right to right, means that we need to use the 100%, the 1 minus with 0.9525. At the end, we get our P, that is this area, the big size fish area is 0.0475. Now we want to write our conclusion. The probability of finding the bawal that is more than 750 gram after convert from gram to the Z to the probability, it is 0.0475 or it is 7.75%. This is a small number, means that it's really difficult to catch that bawal fish in the lake. We can ask the lake owner to help us because he's more experienced, and maybe we need to pay him to catch the big size bawal. Now we want to help Jerry. Jerry, he wants to catch 4 bawal fish as long as the average is 750 grams, more than that. We are going to use these 4 steps to help us too. First step is, what do we want? Me and Jerry, we want to catch 4 bawal fish. Average is more than 750 grams. We want to find what is the probability of catching these 4 big bawal fish. If the probability number is big, means that it's easy to catch. Step 2, what do we have? We have the same information, that is the population mean 600 grams, the population standard deviation is 90 grams. Because for this problem, we want to find the sample average, means that our problems fall under the sampling distribution model, means that we're going to use the formula here. Step 3, how to solve, how to find the probability number. We're going to follow the start 3 steps here. The first one, we want to mention that this problem is modeled under the sampling distribution model. Step 2, we want to convert from the weight to the Z score, and later on from the Z score to the probability. So the second one is to use the Z formula here, and then the third one, to convert from Z score to the probability, we still can use the Z table because we have the Z score number. Step 1, our bawal weight can fall under the sampling distribution model here. 600 is the population mean, and then 90 square is the variance, that is the standard deviation square, and divide by how many fish that we intend to catch to find the average. So n later on will be 4 here. We're going to write our probability definition. We want to find what is the probability of catching 4 fish average is more than 750 grams. From gram, the weight we want to convert to the Z score. So we will replace the 750 gram with this formula here. the x bar minus mu divided by the sigma and divided by the n. The x bar here, this one is the average weight that we want. We want 750 gram. Mu is the population average, population mean 600, and sigma is 90, the standard deviation. And last one is the n is we want to find 4 fishes. So later on we get the z is larger than 3.33. Again, we want to use the z table to convert to the probability number. From the z table, we want the z 3.33 intersect at this red box here. So this red box means that the probability from left to right, a huge area there. What we want is the tiny right to right area. So we take 1 minus 0.9996. What we get is our P is 0.0004. Very small number. Next one, our conclusion. The probability of catching 4 fishes that would be average more than 750 gram is a very small probability number. Means that it's really difficult. The lake owner might also difficult to catch this fish too. For this problem, we would suggest Jerry maybe to lower down the average weight, not 750 gram. Why not we consider 650 gram, the average? Then suddenly there's a bad news. The owner suddenly says that, oh, I'm sorry, I actually don't have the population standard deviation number here. I don't have it. But if you want to find what is the sample standard deviation, you just take that 4 fishes weight and then use the standard deviation formula and find it. And assume that we already did the calculation. Our number is 120 grams. We're going to follow for step 2 to find what will be the new probability. If we don't have the population standard deviation, if we don't have this one, will our probability number increase, same, or decrease? Step number 1. This is what me and Jerry wants. We want to catch 4 fishes. Average is more than 750 grams. Only that this time we don't have this number. We don't have the population standard deviation, the 90 grams. Step 2, what do we have? We have same population mean, except for the population standard deviation we don't have. We have the sample standard deviation. This problem, because we want to find what is the average sample weight, so we're going to use the student t-distribution. We want to mention that this problem can be modeled under the student t-distribution. So we'll say that our average weight of the fish falls under the student t-distribution here, and our degree of freedom is 4 fishes minus 1 equals to 3, the degree of freedom. 2, we convert the weight to t-score. No longer convert to z-score because we don't have the population standard deviation. So we use the t-score formula to do the conversion. And step 3, this is the hardest part. We want to convert the t-score to the probability number. Okay, we have the the statement saying that the problem can be modeled under student t-distribution. The second one we're going to write. We want to find the probability of these 4 average fish is more than 750 grams. So we're going to convert to t-score using this formula. So we have the x bar is what we want. What we want is 780 grams 50 grams. The mu is the average population. The S is the sample standard deviation, 180 grams, and divide by cert n. This is how many fishes that we intend to find the average. So we have our t is greater than 2.5. Now we want to use not Z table, we want to use the T table. Where can we access the T table? One place is ttable.org. Go to this website, then there is quite similar table will appear here. There will be roughly 4 big steps to find what is the probability. The first step is to highlight what is our degree of freedom. Degree of freedom is what is our number minus 1. So we have 4 fishes minus 1. So later on will be 3. First step is to highlight the whole row. The df equals to 3. Second step is to narrow down where is our 2.5 located at. So 2.5 is between these two numbers here. So our 2.5 is in between these two numbers here. Step number 3 is to mirror where is our probability. So when we have that 2.5, so we're going to mirror up. The P will be 0.05, 0.025. Means that later on we will calculate somehow to find the P, and our P will be between 0.05 to 0.025, our P number. How to find our exact P number here? So we can use this arrangement. So we don't know our P, so we take our P as the unknown here. So 0.05 minus P, okay, will equals to the mirrored 2.353 minus 2.5. Then divide by 0.025, the right side, minus P, equals to the mirror below 3.182 minus the 2.5. So later on after the calculation, so we get our P equals to 0.046. So we have the P is 0.046. Now we want to write our conclusion. What is the probability of catching 4 fishes with the average is more than 750 grams? 0.046, there will be 4.6%. So it is quite having the chance to catch these 4 fishes that is very average, very big size. So for this problem, we might ask the lake owner to help us. Okay, before we end the session, go to your eCampus. You watch this YouTube done. So later on, using the 4 big step formula format, solve the same 3 questions here. The Tom 1 question and Jerry 2 questions. After you solve it on your paper, snap photo and submit to the Google form. And later on, go to scan your attendance at that link there, Pioneer F23 friend, and our session will be ended. Okay, take care. Bye bye.